Solution for first internal information security. In this internal question paper, we have to attempt only 2 questions. So I am gonna attempt first question, that is question number 4, the public implementation of reversed Shamir and Elderman with P is equals to 7 and Q is equals to 11. So let's move on to the solution video. The solution for RSA involves some steps which needed to be solved to find the solution. So RSA, which is reversed Shiver Elderman, which is an asymmetric key cryptography in which we use 2 keys, one is public key and one is private key. So let's look at the solution now. So we are given 2 values of P and Q, that is 7 and 11. So the first step for public key implementation of RSA is first selecting our prime numbers P and Q. Then in second step we calculate n by multiplying our values P and Q. So 7 into 11 is equal to 77. Now in the third step we calculate phi of n, which is basically calculate using subtracting P with 1 and Q with 1. So 7 minus 1, 11 minus 1. So the answer is 60. Now choose the value of E such that E is greater than 1 and less than phi of n, and the greatest common divisor of phi of n and E must be 1. So in this case we are assuming that 7, because 7 is greatest common divisor between 60 and 7, that gives 1, and 7 is between phi of n and 1. Now fifth step is calculating the D using the modular inverse, that is ED or DE mod phi of n is equals to 1. So D into E, that is our 7 mod 60 is equals to 1. So we will get D is equals to 43. Now in sixth step we have to write public key. So public key is given by E comma n. So E is 7, which is we have found in the fourth step, and n is our 77, which is calculated in our second step. Now seventh is calculating the private key. So private key is given by D comma n. So what is our D? So D is calculated in our fifth step, that is 43 comma 77. Now to encrypt the cipher caps we need to find the public key. So public key is given by let's see the 8th step, in which we have given by formula C is equals to m to the power E mod n, where m can be any number less than n, that is m can be less than 77, any number. So in this case we have taken 9. So 9 to the power 7. Why 7? Because our E value is 7. Now 9 to the power 7 mod n, mod n is mod 77. So what will we get? We will get 37. So our ciphertext is encrypted with public key, that is 37, which is our public key. Now ninth is to decrypt using the private key. So for decryption we used formula m is equals to C to the power D mod n. So what is C? C is our ciphertext which we have encrypted using that number, that is 37. So 37 to the power D. What is D? D is calculated. So D is 43. So 37 to the power 43 mod 77, which is mod n, is 9. So we can encrypt using 37 and decrypt using 9. So this is how the public key implementation of RA is implemented with the values of P is equals to 7 and Q is equals to 11. So this is all about the solution of this question. Now let's move to question 3, that is suggest recent malware analysis techniques. So what is malware analysis? So it is basically the process of analyzing malicious software and understanding its impact on our system and how much potential it can affect or damage our system. First one is behavior based analysis. In this we analyze the behavior of the malware in an environment, like understanding its action including the network communication, the file changes or the system modification it is doing. So this is help in detecting the new and unknown malware. The second is machine learning. So machine learning techniques can be used to analyze the malware and classify it on the basis of its characteristics. So how machine learning is going to analyze the malware? So it works on the data set which is defined about the patterns and behaviors of the previously identified malware. If that malware is getting connected with the malware characteristics which is identified now, so this can help to analyze it. Next is sandboxing. Sandboxing involves running the malware in a controlled environment to identify its behavior. So like virtual machine to identify its behavior and malicious activities. The next one is memory analysis. Memory analysis means examining the system memories for tracing the malware activity. So any change in the memory can be affected by the malware can be identified. Next one is reverse engineering. It involves analyzing the code of the malware to understand the functionality and purpose. This is often used to identify the inner workings of the new or unknown malwares. The next one is automated analysis. Some automated analysis tools are used to analyze the large number of malware samples. This can detect the malware signatures, unpack and deobfuscate code and extract the information about the malware's behavior. The next one is signature based detection. In this, the signature based detection involves comparing the digital signature of a file to a database of a known malware signature. If both them get matched, then the file is flagged as malware. The next is heuristic analysis. It involves looking for suspicious behavior and characteristics in files and programs that may include the presence of the malware. Next is Yara. Yara is a rule-based language. So you can create your own custom rules to detect malware based on a specific pattern or behaviors. The next is network analysis. So in the network you can monitor the network traffic to detect the communication for a malware or command and control servers as well as suspicious activities. Sometimes firewalls can also be used. So this is all about the solution of the first internal. Thank you.